Oh, okay.
Oh,
sorry. Les Dennis, I think, is in Panto at the moment.
Is he really?
Yes.
In Southampton?
Yeah.
Oh,
I think
okay.
it's Les Dennis. Yes, I think it's Les Dennis.
The things you learn. So, good evening. My name is Gavin Payne. I am a consultant for COIO, who are a SQL Server Microsoft Gold partner in the UK and Europe. We deal with complex mission-critical SQL Server environments, Engine, BI, work with some of you guys in the room, and we are probably a face and a name that you'll recognise from SQL Bits and other events. So that's who we are, that's who I am. My background myself, I'm a database engine consultant, senior consultant for COIO, and I'm also our virtualization specialist within the company. Hence, I do quite a few presentations, training, workshops for clients on this topic. So I guess my first question for everyone here tonight is, what's the balance between BI, dev, operations? So who here works with BI? Developers? Okay, and operational? Okay, so we've got a mix. So I'm quite conscious that when I've done training sessions and SQL conferences sessions before, people have chosen to go to a session about virtualization for an hour. You as BI or dev people probably don't want to go and voluntarily listen to the depth that you made at SQL Bits. So I'll try and keep a good balance of interest and fact and detail for everyone. So if you do get sort of frustrated that I didn't mention something, please feel free to ask me at the end.
Are you doing a training course soon?
Am I?
Doing a training course for devs soon?
That's gone.
Oh, it's gone, sorry.
So really, I guess we'll start off today looking at virtualization today. And really, I want to sort of understand what people's experiences are and what you use it for. So I guess my first question for you is, really broad range of people in the room. Who here uses virtualization at some point today? And that's really sort of interesting, given that we've not just got operational people, we've got BI, we've got devs. I guess one question we could ask is, do we include cloud computing? So virtualization is really the foundation for all the cloud computing technologies and providers that we see out there. So if you use something like Windows Azure or AWS, you are probably transparently using virtualization, even if you're not aware of it. So the two technologies do really go hand in hand. Virtualization is really a cloud computing enabler when you look at the technology stack. So for those of you that use it, what advantages does it give you? What disadvantages do you get? What are kinds of, what really excites you to use it? What really, do you hate to use to have it?
I've had some issues on slightly higher end systems with I/O compute sort of operations.
Yeah.
There's a lot of that disappears when you go back to sort of bare metal. But
okay. So I guess
we're just using it wrong for the wrong workload. Yeah.
So to summarise there, we've got a right-sized virtualization configuration for the workload. That's something we mentioned. Anyone else? Anyone got anything exciting that the reason why they really love using virtualization?
Just ease of provisioning.
Yeah. So ease of provisioning. If you're a virtualization administrator, rather than having to buy a physical server and put it in the rack, you can self-deploy VM in a couple of minutes. That's a good point.
You can have your own internal networks and Active Directory and all sorts.
Yeah. So I guess as we'll see in a bit, we can use virtualization to provision complete mini environments for developers. So you could give every developer their own 6-server test environment, which we just wouldn't be able to consider sort of 3 or 4 years ago.
So on the disadvantages, I don't know if you get this, but the deal with people virtualization, it probably sounds really stupid. You get some people who lose sight of the fact that it's actually physical hardware that has to underpin all this.
Yes.
I've worked at places that have had terabytes and terabytes of virtualized infrastructure, and they say, well, I'll just card you a virtualized disk as the same, and you think, well, that's nice. I know, if there's like a storage array or a HP EDA, and I can't go down to the physical disk level, but it'd be nice at the very least to sort of say, I have temp DB off this law.
Yeah, absolutely, and that's something that we'll look at. So even when we virtualize, especially in the SQL Server world, SQL Server still has its operating practices that if you meet, will allow it to excel, and that's something that we'll cover today. So I guess the final question there, sort of collectively, or what would we do without virtualization? I think as we've mentioned, we would actually have dozens more physical servers than we have today. We'd have old servers, a little bit risky. So I guess what it's allowing us to do is that whole range of quickly deploy in bulk, and also manage things more easily, which we'll mention. So, why do we virtualize? The red doesn't really show out here, so you'll just have to imagine a nice dark red banner there. The primary reason that most people will say when they say, well, what's the point of virtualization, is probably the original adoption reason. It's not the only, and today it's probably not the most important. So people originally adopted virtualization to reduce cost and reduce risk. And we'll cover how that works in a moment. But really the idea was that I could deploy fewer physical servers than I'm used to. They're a bit more powerful, so there is a trade-off that we have to remember there. We might deploy fewer physical servers, but those physical servers need to be more powerful to still give us the capabilities we need. So we can deploy fewer servers, which is really a goal for the guy that likes to count servers in the data center and keep that number as small as possible. We can also run our older workloads on newer and safer hardware. So we can take virtualized snapshots of old physical servers and run them as new virtual servers on newer hardware. So if we had a 10-year-old server that was running an old finance system, that 10-year-old server, we can take out a picture, but we don't have to change anything about the finance system. So that's something that we often overlook, is that it's a risk reduction as well as a cost reduction. And I think, as we mentioned earlier as well, we can reduce our deployment times. So if we do have a really dynamic dev environment, test systems, I want the server up for a day, I need a new test environment for a week, we can do that, we can provision that in minutes, not days. But I guess also what we need to reflect on is that when we start to look at the bigger environments, those reasons are totally ignored. There are other benefits around virtualization that we see people considering now around increased functionality. That is the reason that they adopt virtualization. And this is really about the idea about being able to provision quickly, about being able to take snapshots and clones of virtual machines, and also virtualization. I won't mention it this evening, but it allows you to do some tricks around increasing the availability of virtual servers. So you might have a standalone SQL server that's not clustered, it's not running editions that can be clustered, it might be running really, really old editions that never even had clustering available to them. If there were a version that you might still run, it could do that. However, by using virtualization itself can offer you some high availability tricks that means that actually I can increase that availability of that virtual server without anything that runs on that virtual server ever knowing or needing to be reconfigured or needing to be compatible. So I guess for those older workloads that might have been running on riskier old single bits of tin, we can now run them on virtual machines that have a bit more protection. So really to follow sort of the same trend, the story that most people will see about when we virtualize is about getting a really high bang for buck. So that's saying, if I buy this physical server, I want to get as many workloads running concurrently on that physical server as I can. I want every resource maxed out. Virtualization for the CIO, the CFO, is a really great way of getting every server to work at 100% flat out all of the time and getting their money's worth. And that's great if you are in a small production environment or you're in a non-production environment. So if you're in a development team, you might have a test server and everybody moans that it's slow and everybody starts their virtual machines and does things at once. It might be slow for your test environment, but you're not in a production environment that is SOA sensitive perhaps. And that's fine. So what that means is that, previously you may never have been able to afford that number of test servers, but now you can, because you can virtualize using a single piece of hardware, but that single piece of hardware runs flat out, and it may be some of the time you ask it to do more than it's capable of doing. And that's fine, because that's really allowing you to provision previously unaffordable systems. So you've got to see that capability as being a positive rather than something that you never used to have. Oh, but we have it now and it's slow. So that's really sort of one step forward to sort of non-production environments. And again, as we mentioned there, when we're looking at this level of deployment, this style of deployment, we were really looking to maximise resource utilisation. And virtualization actually brings some features, some technologies to the table that allow you to really exploit every bit of hardware and server. Question?
I was going to say, having a test system on fast hardware can actually lull you into a false sense of security. In many respects, it's better to have it running on something that's a bit slower.
Okay.
So you can then, you're much better off, much better able to see where the resource bottlenecks are. And it's, so if you can get it running decently on a virtual machine, when you put it to the real thing, it will fly.
Yeah, and I think what we can also do is we can also set the expectation with developers that this is not production grade hardware. So it will run slowly. The reason it runs slowly is because we're able to give you this in the first place. And yeah, you're quite right, if it runs great in test, it will run fine in production. So that's really that high bang for buck direction. The other sort of the opposite end of that scale is really moving towards high stability per buck. And this is where we start to see the trend of the behaviour around enterprise-grade production systems. So all of the technology that virtualization brings to the table to allow us to really maximise our resource utilisation, to over-provision resources, to make them really, really work hard. Enterprise production environments, they switch all that off. They don't want anything that can really put any risk towards the performance, the stability, the certainty around that performance level anywhere near them. So they say to VMware, it's great you've got this feature, but we're not going to use it. Ironically, VMware also in their best practice documentation for SQL Server, they will also tell you not to use some of the great features that they put in their software to maximise your hardware. What they do want though is some of the management, some of the functionality around provisioning systems and EHA. That's the real goal for those enterprise production environments. The fact that actually it brings new technology around maintaining and delivering an environment rather than actually delivering the same environment but a bit more cost effectively. So two quite different ends of the spectrum when it comes to how we can use virtualization. If you're very, very much used to the high bang for buck end of things where your virtual server is always running flat out, you need to consider that actually when you move to production it doesn't always have to be like that. So some companies will choose not to allow that situation to ever happen, and what they do is to be able to do things around the management provisioning that they could never do in the physical world. So does anyone have any experience of, I guess, either of those, or do you sit in the middle? What's people's sort of feeling there?
Seeing people deploy our software into virtualized environments, we say yes, we support it, and it can run in a virtualized environment and really completely my life just get sucked out of the system. So we've not provisioned it correctly.
Yes. So both of these, I could say your software's running on a virtual server. It could run really, really badly on this end. It could run really amazingly at this end. But I could still use the tagline, it's running on a virtual server, and that's where it becomes really difficult.
Previous place that I went there, it was VMware 4, and they had high availability and low balancing across three systems. And at one point it ended up with 90% of the VMs running on just one of the machines because they weren't really compatible running the two together, which is exactly what you're saying now.
Yeah, so I guess what this is saying is that we've probably only ever heard this media story around virtualization being a cost saver, being a really great enabler to really maximise server usage, as we'll see in a minute. But there is another end to the story, and this is the end that the enterprise is adopting for their production environments today. So when we talk about getting, the most bang for buck out of our hardware, this is really focusing around contention. So this is saying, I've got a load of workloads that all want to use the same bit of resource. They all think they've got complete access to the resource, but I know that they will never need to use the full amount of that resource at any one time altogether. So I can probably do enough clever time slicing to make them all think they've got the full resource, but they'll all happily coexist. So I use the terms good and bad contention. Good contention is what virtualization was designed to allow. Bad contention is when you implement it badly, and that's why you get issues with performance. So if you look at the task manager screenshot on the far right of your screen, you'll see CPU usage, which might be a really typical example today of an application server, a domain controller, a file server. There are probably dozens of servers out there in your estate today that have an average CPU utilization of less than 15%. And that's really what the CIOs, the CFOs really focused in on, was actually, I know, most of my servers have got 95% free capacity, they only use 5% of their capacity. So can't I actually put 20 of those workloads on one server, get rid of 19 and just have one that's running flat out? That's really sort of the fundamental concept of contention. You know, let's take 10% workloads and move it onto one server running at 100% and get rid of the other 9 servers. You need to plan around that carefully. So we mentioned, in the 5% example, you could consolidate 20 to 1. So that's an example of a contention ratio. I can take 25%, that equals 100%. I can get 20 to 1. Realistically, what you would probably do if you were taking that approach is contend on a 10 or 15 to 1 basis. So if that really was your average CPU usage, you would still give yourself some headroom, some room for manoeuvre if things were busy. And that, in older environments where they have dozens of old servers, rackloads of old kit, was a really good approach to getting rid of those old servers, cutting down power and cooling. The challenge you have is when that 5% suddenly jumps up to 60%, and there isn't enough 60% to go around. So what happens in those instances is I could potentially be trying to get 1200% CPU utilization in total out of my server at this point, if I had 20 virtual servers all wanting to use 60% of total CPU resource. The problem that we get then is what I call bad contention, and this is where the virtual servers no longer always have every bit of resource they need freely available to them. Previously, if we were consolidating on a 10 to 1 at 5%, half the server would never be used. So it would mean any virtual server would always have every bit of access it needed. There was no latency, there was no time slicing, there was no tricks having to be done to find resource in a hurry. When we move to this bottom scenario, bad contention, the hypervisor, which we'll see in a moment, is the piece of controlling software for virtualization. That's now having to control this access to the resource. There isn't enough to go around, but it's promised everyone there is. So it's now having to allocate on a priority basis. You think you've had this resource, but I'm going to make you wait a little bit until it really becomes available. And ultimately, the bottom bullet point there is the problem that you will have in high performance and production environments when this bad contention happens. You can no longer be guaranteed access to the resource, so you can't guarantee the consistency of your performance. So that's probably sort of the good side, the bad side. People only ever talk about the good side. People also, as we'll see in my example, they only ever mention CPU usage. There are a dozen other factors that you need to measure and calculate before you decide how you contend. But that's really the media story. If you're new to virtualization or a CFO says, why should I virtualize? That top one is the story he'll get told. You can get rid of 19 servers if you make one server really, really busy. So I think, as I mentioned to somebody asked me in the break, what makes a good candidate to virtualize a server? So people often ask me, what's the biggest server you can virtualize? You can't talk about big. I could give you a really small SQL server, I'm sure you will have one, or a small web server, reporting services or an integration services host. It's got a tiny footprint, but it runs flat out at certain times of the day. At the other end of the spectrum, you might have a massive server running a data warehouse or reporting databases that's massively over-specced, a lot more resource, but a lot lower utilization. So they're very, very different types of workload when it comes to sort of saying, well, what makes a good candidate for virtualization? So people often ask, is it about small, medium and large? And the actual answer there is it's more about the workload. So it's about quiet, active and busy. So if you're a web developer and you're being told that you need to host your software on virtual web servers, you need to start to consider actually, well, what's the workload? Am I likely to run into resource and contention issues because I know my web server is going to be really, really busy? Or actually, is it just quiet and it doesn't really notice too much about the environment it's in? So they're the terms that I use. They're very, very different in terms of their meaning to small, medium and large, but they are quite measurable, or we emotionally know if the server feels quite active or busy. And then really, my experience to date, Virtualizing these quiet servers, so this could be your HR system, your expenses system, your entry card logging system. That's what I would call a quiet system. Virtualizing them is the norm now. You would never physically buy a server, a physical server, to run a tiny little database application on, whereas 5 years ago we had to. So virtualizing those is the norm. Virtualizing your active servers, so this could be your finance system in a mid-enterprise company. It's quiet with a dozen data entry clerks for most of the month. There's a couple of busy days at the end of the month, but it's pretty generally happy with the amount of resource that you've got. Nobody ever phones you up to say it's slow. Everybody knows it'll be slow at month end, but that's the type of active server where we should be able to virtualize that if it's got some good virtualization practices behind it. If your virtualization admin, tells you he's going to virtualize your environment on the same day that he receives the manuals in the post, it may not go so well. If you've got an experienced IT team, it should go well. The red label I've got there for busy servers, so these are almost certainly going to be, the online e-commerce trading platform databases, the really busy transaction systems, 24/7. They're the types of environments which, when I see them, they always have locking, blocking, and deadlocking issues. They didn't scale. They've got poor indexing, high CPU. They're busy. They're a pain to manage and keep stable, even on physical servers today. And yet somebody says, wouldn't it be a great idea to virtualize them? You can virtualize them, but it will need planning. VMware and Microsoft with Hyper-V 3 and Windows 8, their marketing pitch now is you can virtualize anything. They have scalability capabilities in their software now that no workload is too big for the current generation of their software. That's probably not too far from the truth. If it's a well-structured, designed environment, their software will almost certainly be able to find and handle most workloads that you throw at it. So what we're saying here is that some systems will work fine, some won't, some will need planning. If people start to talk to you about systems that need to be virtualized, start to think about what do you call them quite active and busy, what's your emotional sort of feeling about how difficult they are to manage today. So I'll go through some terminology that some of you will know inside out, some of you might be new, sometimes some of you may not have seen the complete picture. So the guest server is Hyper-V's terminology for a virtual server, a virtual machine. This is actually, this is the virtual environment that runs its own instance of Windows that you will run, SQL Server, IIS, is talking, and there will be dozens of these in your virtualization environment. So that's really the end product of everything virtualization does, is giving somebody somewhere one of these. And that normally runs on a layer called a virtual machine manager. So in the bigger VMware environments, this used vSphere and it was controlled by vCenter. Microsoft had their equivalent products with System Center and Hyper-V Manager. So we had this control layer. This was really the admin interface into the virtual environment. And then we had our TIN, the physical layer. So this was 1, 2, 8 environments I worked in before had 256 host servers. So these were regular physical servers that you would buy from HP, put in a rack. But rather than installing Windows on them, in the VMware equivalent, you installed a piece of software called a hypervisor, and that is its own mini operating system that allows this host server to be controlled and run guest servers. And then to make things all really smooth in a mid-sized environment, you would then use a SAN that had shared storage that each of these could access. So is that useful for some people that have not seen that all in one slide before? I'm never quite sure if that is a good way of describing it. Most people only see this level. This is what sits behind it. You probably hear about the hypervisor, but this is really sort of the infrastructure. So why has designing platforms changed when we've moved from physical to the virtual world? So this is the bit which, ironically, most people overlook. They think that when what we had in the physical world, we can still apply the same design principles, and monitoring principles, management principles, troubleshooting principles to the virtual world. So whether you are an ETL developer, whether or not you're a database developer, whether or not you're a DBA or a sysadmin, you will have an interaction with one of these layers of the stack, typically, or you could be an end user coming into the top. In the physical world, we would have a server that did all of this. So we would have a physical box. We knew that every bit of resource in that physical box was only ever going to be used by anything further up the stack. So if we had 16 gig of memory in the server, Windows would see 16 gig of memory, SQL Server would see 16 gig of memory, and so on. And that made it really, really easy because we didn't have to worry about what anyone else did. The only people that could affect anything in this stack were other members of this stack. And we could, when we came to troubleshooting, we could look at each layer and we could look at this whole environment in isolation. The challenge that we have when we move to the virtual environment is that firstly we have a new layer, but also these three layers are now shared. So the big change that we have now is that somebody else's SQL Server engine could be affecting my server hardware performance, which then affects my SQL Server engine. So by having these shared tiers in the stack now, that totally changes our approach to troubleshooting, to capacity managing, and also saying, well, actually, where might the issue be? Before we were confident that the only people that can affect our behaviour were us. Now I can have a really noisy neighbour that shares my host server, shares my SAN, and actually that brings down my application logic at the top. So that hopefully will help you visualise really that expanded stack, and also what is now shared and not necessarily shared with good people that you're aware of what they're doing. So SQL Server and virtualization. I guess the slides up until now have all just been about generic virtualization. There's a reason for that, because SQL Server doesn't really behave very, very differently when it's virtualized. Most applications don't. Most applications, all they ever need is CPU, memory, and storage. As long as you give them enough of that, as long as you give it in a performant way, they will operate. SQL Server is no different. SQL Server is no different when that's running on virtual rather than physical. So SQL Server, when you start it up, it will detect or report that it's running on a virtual server. There is a DMV, sys.dmos sysinfo. Has some columns that tell you about the server type it's running on. There's a tiny bit more information about that in SQL Server 2012. It is purely read-only informative information. It does not influence any behaviour. So SQL Server does not say, I'm running on a virtual server, so I'm going to give you new error messages. I'm going to enable some new features. It's not going to change any way that you interact with SQL Server or any of the error messages that you ever get, just because it reported that it ran on a virtual server on startup. There's one tiny little exception that we'll mention in a moment, but when it comes to you doing your day jobs, whether you use SYS, reporting services, or SQL Server, the very fact that you're on a virtual server is not going to change functionality. What it may change is your access to the resources that you need to run everything at the speed that you like. So that's probably the big change, is that it's far easier to have the resources that you need taken away from you. So there is one change. Hot add memory is a legacy, it's not legacy, it's in the product. So it was a feature that came out in 2005 Enterprise Edition. Hot add memory was designed for these massive servers that were going to run SQL Server that were the size of mainframes, that had 32 CPUs, 8 terabytes of memory or something crazy. And they were so huge they were going to be up forever, they were never going to be restarted, and you could physically upgrade them in real time. So you could plug more memory into the server physically, you could flick a switch and then SQL Server would magically recognise the new memory that you just plugged in a few minutes ago and start using it. To do that, it had to have a couple of features in Windows to support that and in the SQL Server engine, and that was called hot add memory. It kind of never really went mainstream. It was a bit like Titanium support. It was a great capability for an era of computing that was pretty low powered. So it went away. However, it does now get used by dynamic memory, which we'll talk about in a moment. So you will see some changes in the product groups, delivery of SQL Server features specific around this area in SQL Server 2012, which I'll contention. So we mentioned earlier our monitoring has to change when we move to this virtual environment. We need to be aware of our neighbours, we need to monitor things. There's still some really bad sources of confusion. So this is running on a virtual server. I bring up computer properties within Windows. It will still tell me I'm running on this CPU core at this speed with this amount of memory. Okay, that is factually true, but there are so many configuration options between that CPU and this instance of Windows that it may be far from the truth and really send you down the wrong direction. If you really think that you've got a 3.1 gig CPU that's running your code, you know, that 3.1 gig could be shared with 20 other users. The reason that this data gets exposed is there are some hardware calls that Windows can make that the hypervisors pass straight down to the hardware. The problem that Microsoft had was if they were to return a synthetic value, what should that be? Because it might be some application software actually does look for a specific CPU type. If you're running the same hypervisor in 10 years' time, should it still return back the same synthetic CPU type? So Microsoft's decision, I'm not sure if it was the same as VMware's, was they will always reply back whatever the hardware gives. So some hardware calls pass the hypervisor, as we just mentioned, and also SQL Server wait stats. So you'll still see the same wait stat errors, counts that you were used to seeing. So page IO latch, SOS schedule yield. Even in the virtual environment though, they're still only symptoms rather than causes. So these are typically two that you will see on any poor performing instance of SQL Server. Can anyone tell me what the two issues are with that?
One's CPU starvation.
Yeah.
So one's IO subsystem.
Yeah, physical IO. So page IO latch is saying that there have been a very high, or there has been an instance of SQL Server waiting for data to be read from disk. An SOS scheduler yield tends to be CPU pressure. So monitoring has to change. One of the problems that we have to change our stance to monitoring is that Windows doesn't know the truth anymore. So when you fire up CPU Task Manager and watch the CPU utilization, what is 100%? You know, 100% of is always a valid number, but it's 100% of what? And that what Windows never actually knew anyway, and that what can be very, very different to what we're expecting. The same with memory. There are very different and clever tricks that hypervisors can do to make you think you've got more memory than you can access, got more memory that you recently accessed that you can't access anymore, or actually you've got a lot more memory that is available to you, you just haven't asked to use it, so you don't know you've got it. So this is really the challenge that you've got. Your approach to monitoring this will vary. And an example, just so you can kind of see the challenge that you have. This is taken within a virtual machine. So I ran CPU stress or one of those tools. This was the virtual machine maxed out CPU-wise. If I looked at the equivalent counter within the Hyper-V hosts monitor, it was telling me that that virtual machine was only using 40% of a physical core. Yet I could be the SQL DBA, I jump on the server in a hurry, I fire up Task Manager and I see 100%. What this shows me is that this server instance or this operating system at the moment is using 100% of the CPU resource available to it. So it's valid in a logical sense. I can say that every bit of CPU resource this instance had, it was using. But I have no idea how much it had. The reason that 40% was in place was because at the Hyper-V hypervisor level, I put a 40% max threshold on the amount of CPU this virtual machine could use. So I could be the DBA monitoring the server and thinking it's using 100% CPU utilization. Why? Well, actually, 100% was only 40% of what you would normally have available to you. Right, wrong, indifferent? There is no answer to that question. You just need to be aware, if you're the type of person that needs to monitor these environments, that you need to get your data from the right source. And my last session, the last SQL bits, was all about monitoring virtualized SQL Server instances. So we mentioned memory. SQL Server loves memory. Windows likes to give memory to SQL Server as much as it can. Hypervisors, though, like to give as little memory as they can. So in a physical server, in the virtualization world, memory is the most precious resource. I can't do anything clever as a hypervisor to make memory do more than one thing at a time. Ultimately, a bit in a memory chip can only store one bit. I can't compress it, I can't... there is a finite amount that you can do with memory to make it go further. So hypervisors now use what I call demand-based memory allocation. So what this basically says is, I've got a physical server, it's got loads of physical memory in it, all of the virtual machines, they need different amounts of memory at different times. So they can have as much memory as they want, when they want it, as long as it's free to be available. And that's great, because if I've got 20 web servers, I don't want to have all 20 boot up with 4 gig of memory, have 80 gig of memory sat there assigned, but only have 16 gig deployed across all 20 because they haven't started doing anything yet. What I may then find is that one web server gets really, really busy, and I do want that one to have more memory than all the others. And that's where this demand-based memory allocation will recognise a low memory condition within a specific virtual machine. It will say, well, that virtual machine would benefit from having more memory. I've got more memory I can give it, so I'll give it to it. You have a question, Mark?
Can it do the same trick with a processor?
So processors, it's always doing that. It time slices, and it's a lot more dynamic and real time in how it allocates.
Apart from when you hard allocate it in the hypervisor?
Yes. So the idea is, and I think I've got a reference in it, that's my only animation rather. The idea is that, yeah, you can move memory between virtual machines based on demand. In Windows, you will see this in the Hyper-V world as your amount of physical memory increasing. So VMware uses a slightly different model, but Hyper-V, which SQL Server is more natively aligned to, will tell Windows you've now got more physical memory, you've got a bit more physical memory, and that comes from that hot memory feature that we saw earlier. So Hyper-V will recognise, as we'll see in a moment, low memory, and it will physically assign more of it. However, we've given all this memory away, there might be a time when you need to get it back. There might be more important virtual machines that need more memory than another virtual machine. And this is where things like weighting and prioritisation come into place. So you can say, if there's ever a fight for memory, these two virtual machines always win. And if you're not one of those two virtual machines, you want to know that you're not, because otherwise you'll wonder why you always run slow and your mate next to you always runs fast. How the hypervisors get their memory back differs again significantly between VMware and Hyper-V, but essentially they have clever ways of getting memory back so that they can give it to other virtual machines. The big difference, though, that you will see is that your physical memory value in Windows never ever goes down. It can go up, but it will never go down. That's a rule within Windows. So if you are using dynamic memory in Hyper-V, you'll see it go up. If it starts to go down, well, it can't go down, but that doesn't mean to say memory isn't being taken away from you.
If the machine restarts, does it revert to the originally assigned value? Or?
It does.
Okay.
Yeah. So one of the things to be aware of, if you fire up Task Manager thinking it's got 16 gig of memory available, it might not. It might have had, but it might not have 16 gig now available to it. And it's beyond the scope of this presentation to say it's going to how that gets taken away and how you detect it, but it's something to be aware of. If you're suddenly getting memory pressure within SQL Server or SSRS and you're on a virtual machine, you may not have the amount of memory that you think you've got right now. So, most detailed slide of the evening, a bit of technical internals overview of how Hyper-V works within Hyper-V's dynamic memory functionality works in Windows 2008. So dynamic memory is the feature that allows virtual servers to be allocated more memory when they need it. Hyper-V has a driver that runs inside the virtual machine. When Windows detects a very low amount of available 3 megabytes, it will go back to Hyper-V and report a low memory condition. If the physical memory is available to be assigned to it, it will get more physical memory assigned to the virtual server, and that's done in the dynamic memory setting. There's an API within Windows called the Enlightened Memory Edition. It's a lightweight version of hot add memory that is designed for the virtual world, so you can actually say you've got more physical memory, you can now start allocating that to applications. The inverse is a ballooning driver. If you're not familiar with that term, but you are using virtual servers, you need to Google that heavily, because the ballooning driver is how your virtual machine gets memory taken away from it. So SQL Server 2008, or I think both versions, Enterprise Edition only, hooks in really nicely to dynamic memory. So far in this slide, the Windows operating system has reported low memory, Hyper-V has assigned it more physical memory, Windows has added that extra physical memory to the virtual machine. SQL Server then notices there is more memory that can be used. So if you are running SQL Server on a virtual server with Hyper-V and dynamic memory, it will detect that and it will enable hot add memory support within SQL Server by default. In the 64-bit world, you can't choose to enable it manually. It's only an auto-detect and enable feature. In SQL Server 2012, this is a major change for the virtualization support guys in the product team. They now support this feature in Standard Edition. So if you run SQL Server 2012 on Hyper-V, you will get this hot add memory support in Standard Edition, whereas before it was exclusively Enterprise Edition. So SQL Server, when it starts with the hot add memory support detected, it will give itself a virtual address space to be 16 times the amount of memory it had on startup. So what that basically says is that I can give the amount of memory that SQL Server has access to an increase of 16 times, and SQL Server will have enough memory address space already reserved available to use it as that memory becomes available. You can't measure that, you can't monitor that, that's an internal behaviour. I know that because the SQL program team now think it's a great idea to be able to expose that, because you can actually, if you could query the fact that these two things happen on startup, it would be a great troubleshooting feature to be able to detect inspiration with dynamic memory. But at the moment, these two options, they're all internal only variables that can't be exposed. So we have a very large virtual address space which can use this extra memory that gets hot added, and the buffer pool is then increased to use that extra physical memory. The size of the buffer pool, as we probably know, can never be greater than the amount of physical memory that we have. And can anyone tell me a big difference in the memory management between SQL Server 2008 and 2012?
2012 was a single memory allocator, isn't it?
Yeah, so this goes back to the 32-bit world. So we used to have the buffer pool, and then we used to have all the other memory that SQL Server needed to use, and we could never configure that other size. So even when we set max server memory, that's only setting the maximum size of the buffer pool. SQL Server could still use a couple of gig on top of that. In SQL Server 2012, the max server memory setting now sets the limit on every bit of memory SQL Server uses. So there is no ambiguity about it could use this amount. So that's certainly something, again, that we integrate better into the virtual environment by being able to set a definitive max server memory size. SQL Cat have a white paper on how to use SQL Server with dynamic memory optimally. Really good white paper if that's something that people work with. So breezing on through storage, do ask me any questions at the end, because I'm conscious that I've got 9 minutes. Why?
About 8 or 9, maybe?
Yes, sorry.
I mean, people will start leaving, so just
That's
keep going.
fine. So I'd rather get to the slides and then ask questions than spoil anyone who's expecting an exciting slide. So storage design is another area that we need to be really, really conscious of when we work in the virtual environment with SQL Server. So even in the physical world, SQL Server loves having multiple isolated, uncontended pots of storage to do different things with. You know, we all know it's second nature that we put transaction logs on different disks to data. It's amazing though when you go to the virtual environment, you can put them all together back onto one big piece of disk. So, as a general piece of advice, for those of you that get involved in this, those of you that might have to ask your sysadmin, are you really sure you didn't do this? Again, avoid one big bucket of storage. You know, if you were to design a physical server with half a dozen internal disks, and you'd say I'd have this for data, this for transaction logs, this for 10 DB, you should be doing the same for your virtual server environment as well. It's only on the biggest of sounds when you tend to say, well, you probably not worry about that. Local server storage in virtual server environments is one of the biggest performance bottlenecks I see. Even when you move to a SAN, you need a very well-structured SAN with lots of isolated pools of disks to still avoid the issue. Again, this diagram here can show how easy it can be to make a hotspot unknowingly. So you might have dozens of host servers, dozens of guest servers, but unknowingly your sysadmin and your SAN admin just all points them to your one LUN, and that's the business LUN. SQL Server doesn't like that kind of thing. You will get high storage latencies. If you start to move to one LUN per virtual machine or multiple LUNs per virtual machines, that's when you start to tip the balance back in SQL Server's favour. So, best practices. This really comes to monitoring. If you are not a sysadmin at DBA, but you're nervous about your software running in a virtual environment, my advice to you is look at the complete picture. So it's all well and great getting real-time performance data, but use other metrics that you have. So SQL Server MSDB is packed full of nice statistics that you can use. So backup times, you can calculate the amount of megabytes a second storage I/O throughput from. If you've got a really CPU-intensive ETL task, again, if that ran for 10 minutes every night of the week, and last night it took five hours, it probably wasn't your ETL job that changed. It could have been the host server that had a problem. So look beyond the SQL Server performance metrics. Look in the terminology you might be more familiar with. Again, this comes back to general performance baselining and knowing when something ran slower than you were expecting. You can use that same approach for SQL Server. So to summarise, there are many reasons to virtualise. We probably only heard about the cost-saving one to start with. There are functionality and manageability reasons to virtualise. So don't just assume that moving to a virtual environment has to be bad. But virtualisation does mean using shared resources. So when we think about those two architecture stacks that we had, whereas before we were totally dedicated, we were isolated, it was only us that could affect our own behaviour. We could have really noisy neighbours now that take away our resources, compete with our resources, contend our resources that we weren't expecting. So our server design and monitoring, so in the SQL Server world, we need to look at how we monitor the performance of the Windows operating system, CPU and memory. We also need to look at the design, so we need to make sure that we have those nice dedicated virtual hard drives, for example,